Your system is only as fast as its slowest 1 cent, and you're probably ignoring it. Introduce tail at scale, where the slowest percentile defines user experience. Google research shows a 63% chance that a request touching 100 services hits a P99 delay. P99 latency, not median, dictates how users perceive your app's speed. Median latency lies. P99 is brutally honest about worst-case spikes. Amazon's data warns, every 100 milliseconds of latency costs 1% revenue on e-commerce. Not guesses. This 1% benchmark is Amazon's 2024 gold standard. Your P99 tail could be leaking millions without a red warning light. Participation inequality strikes too. 1% create content, 9% curate, 90% lurk. That 1-9-90 split forces a 100-to-1 read-to-write ratio in your databases. DynamoDB and Cassandra clusters groan under those extreme read demands. Indexed or not, your storage model must handle 100 reads per write. NVIDIA's 10,000-node H100 GPU clusters lose 50% throughput from 1% failures. Checkpoint and resume on every failure means half your GPU budgets vanish. These aren't fringe cases, they're the linchpin of any at-scale system. Mobile users punish slow tails ruthlessly, and session drops spike. Akamai data proves it. 100 milliseconds of P99 improvement boosts mobile conversions by 11%. That 11% swing is actual profit, backed by global CDN metrics. Netflix's chaos engineering digs into the 1% rare cascading failures. They automate inject faults to prove 99% core services survive AWS region outages. SREs' 1% error budget compels immediate feature freeze at critical user journeys. Miss that threshold, and deployments halt until your stack is hardened. Elephant flows. 1% of high bandwidth transfers hog 80 to 90% network capacity. Without special traffic shaping, your mice flows experience starvation and timeouts. Cisco NetFlow data confirms this 80-20 hogging in backbone routers. Partial indexing targets the hottest 1% of rows, slashing I/O by 80%. PostgreSQL demos show real cuts in disk traffic when you pick your 1%. MongoDB yields mirror that, proving cross-engine gains from selective indexing. Letting 1% of code rot each sprint balloons technical debt by 30% over 2 years. DevOps surveys show this compound effect choking developer throughput industry-wide. FedEx to Stripe, every fintech giant obsesses over P99 latency. Uber tames P99 spikes with hedged requests to alternate replicas. Resend after a 95th percentile wait and watch tail dive. Uber cut their P99 latency by over 80%, driving happier riders. Even they bow to the 1% rule. No service is immune. NVIDIA's 10,000-node H100 clusters illustrate GPU fragility under tail failures. A single node failure triggers costly checkpoint cycles across the farm. Prometheus histograms miss those spikes if you only chart averages. Observability tools must expose P99, or they lie to you. SRE playbooks ban tail spikes. Teams embed this in runbooks. Injecting chaos finds those hidden 1% security vulnerabilities. Zero-day exploits target that 1% of rare code paths, rising 20% annually. Zero-trust architectures quarantine every JIT admin request to block breaches. Just-in-time access now default in Azure and AWS IAM. You can't patch these tail modes once you're in production. Content platforms live the 1990 reality on every page load. Wikipedia's edits show 1% of users write nearly all articles. Reddit's 9% of mods curate the firehose for 90% passive lurkers. That forces 101 read-to-write schema designs in your DB. Cassandra and Scylla replicate hot partitions to balance reads. Cache hit jumping 98% to 99% effectively doubles request throughput. Reducing misses halves traffic to primary databases at scale. Akamai edge caching applies the same 1% rule to assets. 1% of files often generate 80% of CDN bandwidth use. Partial indexing picks these hottest keys for ultra-fast lookups. Dropbox shared this in their engineering blog years ago. This trick slashed their query latency by 60% overnight. Use heat maps in your metrics to spot that top 1%. Tag and index them separately. Don't bloat your full index. That alone can push performance from good to runway speed. Global data centers will consume over 1,000 TWh by 2026. Power-aware design refactors the 1% hottest algorithms for efficiency. Optimizing that tiny fraction can cut cooling costs by 15%. Google's data center team led this saving with thermal profiling. They found 1% of routines drove 40% of heat in racks. Rewriting those kernels reclaimed millions in annual OPEX. SRE error budgets enforce 1% failure ceilings on critical flows. Cross-team drills now lock feature launches when budgets threaten. Paid performance, not hopeful promises, wins boardroom debates. Netflix's chaos tools hit that elusive 1% cascading scenario monthly. That discipline prevented a 2023 regional AWS outage from taking us down. Founders must budget for chaos. It's an operational line item now. It's insurance against your worst 1% failure, not a luxury. Ignore it, and you'll pay in downtime and reputation hit hard. Scale without this is like flying without emergency protocols. Spear phishing zeroes in on that critical 1% of admin accounts. Security teams report 90% of breaches originate there. Palo Alto Networks sees this trend climbing every quarter. Zero Trust and JIT access are your 1% bulletproof vests. Azure and AWS default JIT for high-privilege operations now. AI clusters see 1% node lags stall entire training loops. Startups often underfund tail optimization until it's too late. Scaling first, optimizing later is a gamble on fragile ground. They raise millions, crash on the 1% storm during peak load. System designers call this compound exposure a debt of extremes. Left unchecked, that debt snowballs like interest on toxic loans. Your next VC pitch may hinge on tail latency SLAs. Boardrooms will ask not just growth, but guaranteed P99 ceilings. Will your architecture solve for that hidden 1% edge case? The future belongs to those who master the 1%, not the 99%.